The area between the parabolas with equations y equals x squared plus 2ax plus a and y equals a minus x squared equals 9. The possible values of a are one of these options. I think I'm just going to write hold on. I mean, computing the areas between parabolas, it sounds like we should simply write that area in terms of an integral. I mean, it's not difficult, but it'll be several steps in that we have to find the endpoints of this integral, and the endpoints themselves will actually depend on a. Okay, let's sketch a little bit about what's going on here to try and get a better idea. And I'll write out the equations of the two parabolas. Y is equal to x squared plus 2ax plus a, and y is equal to a minus x squared. So a minus x squared is pretty easy to sketch. Just looks like that, where the vertex is at a, but x squared plus 2ax plus a, when a is equal to, obviously when a is equal to 0, we just have the standard parabola like that. For positive values of a, it gets moved like that, and I believe, hold on. No, it'll get moved to the left, but it'll also, positive values of a, it'll look something like that. And for negative values of a, it'll look something like that. So, yeah, I think the first thing we do here hold on a second. When x is equal to 0, the first parabola always goes through a. So in fact, my diagram is a little bit misleading. For positive values of a, the figure looks more like this. And for negative values of a, one parabola is opening downward like this. It's opening downward with an intercept at a, and the other parabola will look something like that. Okay, so what I am going to set this up in terms of integrals, and the endpoints should not be difficult to solve for because we know one endpoint is always going to be 0, right? There's the area between those two parabolas for positive a and for negative a. It looks like that. So let's solve for when these two things are equal. We have y is equal to x squared plus 2ax plus a, and y is equal to a minus x squared. If I set these equal, x squared plus 2ax plus a is equal to a minus x squared. So I have 2x squared is equal to negative 2ax. So clearly x can be equal to 0. If we get rid of that root, we have x is equal to negative a. Okay. Is one parabola always on top? Yes, the one that opens downwards is always on top. So I'm integrating. There's going to be two answers here because of the symmetry of the problem. One value of a is going to be positive and one value is going to be negative. So let's start with, let's assume that a is positive. So we have an integral from negative a to 0 of the downward opening parabola, a minus x squared, minus the upward opening parabola, x squared plus 2ax plus a dx, and this is equal to 9. So we're going to compute everything here, evaluate the integral. We'll get an expression in terms of a, and then we should be able to solve for a because this whole expression is equal to 9. So I have a minus x squared minus 2ax minus a dx is equal to 9. So in terms of antiderivatives here, I have so this has to be evaluated at negative a and 0. So substituting 0 gives us 0, of course. And then I subtract all this evaluated at negative a. So I have negative a cubed. I hope I'm not mixing up negative signs here. Minus a cubed is equal to 9. What? I'm sure some negative signs got screwed up there. Okay, hold on. Ooh, also my antiderivative was wrong. X cubed over 3 times negative 2 minus ax squared, evaluated at negative a and 0, is equal to 9. Okay. So subtract the antiderivative evaluated at negative a, negative 2 over 3 negative a cubed minus a times negative a squared is equal to 9. And I have negative a cubed over 3 is equal to negative 9. So a cubed is equal to 27, and a is equal to 3. That's when we assumed that a is positive. If we assume a is negative, then we're in this situation, and we have to integrate. We have to switch the order of the integral. So to compute the area, we would have to integrate from 0 to negative a. And keep in mind, because a is negative, negative a will be positive. This ordering is the same though. And so what would happen when the only thing we're doing is switching the orders of the integral for this expression. So that'll pop out. I'm not going to go through all the work, but also a equals negative 3 will work. And this is option B. Yeah. Yeah, pretty sure everything was done correctly here. Understanding the geometry graphically what's going on with the problem certainly helped. My original sketches were definitely misleading. I didn't clue in that the two parabolas will intersect on the vertical axis when x is 0. And then also just understanding what the figure looks like for positive values of a and for negative values of a kind of helps to see that the problem is going to be very symmetrical. Yeah, like by moving from positive a, by redoing this with negative a, you have to swap the order of the bounds of integration simply because you're now integrating from 0 up to negative a. But you'll notice the downward opening parabola is always the one on top. So you don't, you won't be switching the order of these two things. You'll keep those the same and set it equal to -9 and then solve. And because the only change you've made is interchanging those two expressions, you just get a negative sign in front of everything. And the cube root will then be -3 instead of +3. Yeah, not much more to this one. But if I think of more to say, I'll highlight it in the video or write it in the description. Thanks for watching.